Hi, it's Doug. You're looking at Mount Everest, the tallest mountain in the world. Mount Everest and the surrounding Himalaya mountains are so tall that astronauts can see their snow-capped peaks all the way from space. Part of what makes mountains so impressive is that they're solid rock all the way through. Like, look, this isn't a mound of individual rocks piled up really high. This mountain is one single solid rock. Mountains are like walls of vertical rock going straight up into the sky. But will these mountains always be there? Do mountains last forever? You might think, well, yeah, why not? But let me tell you a story. A story about not a natural mountain, but a mountain made by people. This, a pyramid. You know, like the kind built by the ancient Egyptians. The Egyptians lived right here, but our story actually takes place on the other side of the world, here, in the jungles of Central America. The people over here made a type of pyramid too, a people called the ancient Mayans. This is the Mayans' most well-known pyramid. It's a great temple called Kukulkan, about 100 feet tall. Now pyramids, unlike mountains, are not one solid piece of rock. Instead, they're built up, layer by layer, brick by brick, using stone bricks that have been chiseled by hand. About 1,000 years ago, the Mayan people abandoned the use of their pyramids. They actually left them, and they went to live in other places. Most of their pyramids became long forgotten. In fact, hundreds of years later, people didn't know many of the pyramids were even there anymore. They were lost in the jungle. What happened to the pyramids? How could something that big go missing? About 100 years ago, local residents were traveling through the jungle and noticed this. Do you see it? It's a giant hill covered in trees. There aren't many hills around here, so that's kind of weird. The residents who noticed got interested, so they went closer to check it out. When they got to the base of the hill, this is what they saw. They noticed that weirdly, the trees had been growing in a pile of rocks. So they started removing the trees, and when they did, here is what they saw. This. Look at that. It's the steps of a pyramid. Once they finished removing all the trees, this is what was revealed. It was one of the ancient Mayan pyramids. It's so cool. So what happened? Well, here's a close-up of one of the trees before they removed it. What do you think is going on here? What do you think happened to this pyramid? The pyramid's bricks used to look nice and straight, but now they're crooked and some have crumbled. What happened? It seems like the trees were breaking the bricks. Is that really possible? For plants or trees to break something as strong as rock? That sounds crazy. Roots aren't that tough, are they? But let me show you something. Here's a whole bunch of solid rock. It's what used to be a lava flow. But the lava cooled, and so now it's solid rock, and it's tough. You would think that it would be here forever, but if you look closely, as it cooled, it left some little cracks. Those are its weak spots. Seeds can land in the cracks. And when those seeds get rained on, they grow. Let's look more closely. Imagine a seed that's fallen in the crack of a rock. Now let's imagine the seed grows a little root like that. And the root will grow, and it'll grow, and grow, until it fills up the crack. Notice that the root didn't just get longer, it got wider too. Now the root doesn't just stop there, it keeps growing. As the root grows bigger, it pushes outwards like this, until, eventually, crack! It breaks the rock, making the crack wider and deeper. Eventually, that section of rock will even split off entirely, creating a new chunk of rock. What you just saw here, scientists have a name for this. They call it root wedging, because a root wedges itself into the crack and widens the crack. So does this explain how large Mayan pyramids could have become hidden in the jungle? Well, think again about what was found. It was a forest of trees growing on top of a pile of rocks, and when they removed the trees, the inner layer of the pyramid was underneath. So now you can understand what happened. Between every brick is a crack. That's a perfect opportunity for a seed. When the Mayans were around, they probably kept their pyramids looking very nice, sweeping away any seeds that might have fallen into the cracks. But when the Mayans left their pyramids behind, the jungle took over. The surrounding trees dropped their seeds into the spaces between every brick, and the roots grew and grew, breaking up the outer layer of the pyramid. That's why, when the Mayan pyramid was rediscovered, it looked like this, just a pile of rocks with trees growing out of it. Now that we know this is what happens, lots of other Mayan pyramids are being rediscovered. Hike around the jungles of southern Mexico, and you might even be the person who rediscovers one of the old pyramids. The first clue is to look for a pile of rocks with trees growing out of it. Now, you may not be planning any trips to the jungles of southern Mexico soon. Still, you can actually see root wedging happening in your neighborhood. You don't have Mayan pyramids in your neighborhood, but you do have sidewalks. Sidewalks don't last forever. If you look around, you can almost always spot at least one section of sidewalk where there's a small crack that's started to form. Just look for the plant or tree that's causing it. It's root wedging. Like, check this out. Can you tell what's going on here? This tree's roots were so powerful that they actually broke apart this section of sidewalk. Just the same as if someone had tried to destroy it with a jackhammer. Isn't that incredible? And look at this. Here's a brick wall that's been cracked, just like the Mayan pyramids. So, root wedging. It's one way that a large slab of rock, like a mountain or a pyramid, gets broken down into smaller pieces. But it's not the only way. In fact, one of the most common ways involves something totally other than roots. Consider again this solid slab of rock, like this lava rock, which left some cracks in it as it cooled. Seeds aren't the only things that can fall into those cracks. You see, as it rains, water seeps into the cracks too. And that alone can cause problems. Water? Yeah, you heard me right, water. Let's look more closely. Here's some rainwater in a crack. Now, by itself, the water doesn't seem like much. But as the year goes on, winter approaches. You know what happens to that water as winter approaches? It freezes. Well, something special happens when water freezes. Do you know what? I'll give you a hint. Have you ever heard not to put a can of soda in the freezer? Why do people say that? Don't put a can of soda in the freezer. Most things, when they get cold, they actually contract or get smaller. But water is weird. Water expands or gets bigger when it freezes. And soda is mostly water. So when you put a can of soda in the freezer, the liquid inside freezes and gets bigger until it splits the can open like this. It can even explode, like this one. If your soda's in a glass bottle instead of a can, that's even worse. You don't want glass flying everywhere. So don't put cans or bottles in the freezer. That's why you hear that. But what does this have to do with rocks? I bet you can guess. As rainwater freezes in the crack of a rocky surface, the water expands, which pushes the rock apart. Crack. We call this, you want to guess? Ice wedging, because the ice wedges itself into the cracks and widens them, just like plant roots. So both root wedging and ice wedging can split a big rock into smaller rocks. Ice wedging is even more powerful than root wedging. The cracks get deeper and wider even more quickly with ice. Look at this. Here's a rock that has been broken up because of ice wedging. You see all the cracks? Here's another one. And look, this used to be just one rock, but it got broken down into smaller rocks, into individual pieces. Ice wedging and root wedging break rock down into smaller pieces. If you walk around at the top of a mountain, you might expect to see only solid rock, but think about it. On the top of the highest mountains, it's often cold, right? Rainwater will freeze. In summer, it might melt, but in winter, it will freeze again. And after all that freezing and melting, the top of a mountain will start to look like this. The surface of the mountain becomes a bunch of smaller, broken up rocks, not all one solid piece. Here's another example of a mountaintop. You see how jagged and cracked all the rocks are? So what do you think? Will a mountain last forever? Well, look at this. This isn't quite as tall as a mountain, but it's still a giant rocky hill. Look at all those splits and cracks. In a few more centuries, as more roots take hold and more water freezes in the cracks, this whole hill will probably split and fall apart into the sea. So we've solved the mystery. Mountains don't last forever. Root wedging and ice wedging breaks them apart.
Can you think of some experiments you could do to figure out what happens to a rock as it tumbles downhill? Think about these questions. Rocks at the top of mountains are jagged, like this. Rocks at the bottom of mountains are more rounded, like this. Why do you think the rocks look different? What happened? Observe the fossil layers below. What do you notice about the layers? The fossils were found under a layer of sand and rounded rocks. Think, how could the sand and rounded rocks have gotten there? Where could they have come from? Let's look at this map of North America. Make sure you look at the key. And think, where are the mountains and rivers located around the Ash Fall Fossil Beds site? Here's the site. Rivers, mountains. Use the map to help you predict how the sand and rounded rocks formed a layer on top of the rhino bones.